This is your Daily 10. Non-calculator, video 11. Make sure you pause the video and attempt each question before you watch the solution. Here's your first question. So this question is wanting us to say whether or not certain averages are appropriate depending on a list of data. It wants us to pick out which one's the most appropriate and give reasons why the other two are not appropriate. So if we start off looking at this list, the reason I'm straight away going to say that mode is not a good average to represent this list is because there actually isn't a mode here. So there is no number that appears more than once. So mode would be no mode, as there actually isn't a number that appears more than once. So that as an average would tell us nothing. The other one that I'm going to discount is the mean. The mean is where you collect all of them together and divide by how many numbers there are. Now that would be fine. However, we have got one single number that stands out as being much bigger than all of the other numbers. So that one would be largely affected by just one of the numbers, in particular the 82. So we would try and avoid using the mean because that is going to be largely affected just by one of those and not by the other 9. So the best average we've got here is the median. It ignores the fact that we've got one very large number and simply finds a number that represents all the others. Here's your next question. So for this one, it looks a lot more complex than it actually is. The square root of 2, and then outside the brackets, to the power of 4. Well, doing anything to the power of 4 simply means you take that number, times it by itself, and again, and again. So here, 2 times 2 is 4, times 2 is 8, times 2 is 16, so all of these multiplied together gives us the square root of 16. But what is the square root of 16? Just 4. So that would be our answer. Here's our next question. So this one, using a little bit of index laws again, we've got that 9 to the power of minus a half. Well, as soon as you see a negative power, straight away 1 over. Do the reciprocal. And at the bottom, we just put whatever the question was, but without the little minus. So 9 to the power of a half. Key one to remember, power of a half means that we'd need to do the square root. So this would give us 1 over, and then the square root of 9. Well, the square root of 9 is 3, so that means that our answer to this is just going to be a third, 1 over 3. Here's your next question. So this question is asking us to draw a cumulative frequency diagram. Now it's given us a table up at the top, 40 to 50, 50 to 60 and so on, and the frequencies. So the first thing we actually need to do is work out the cumulative frequency. Now we could do a full separate table, making numbers in here 40 to 50, 40 to 60 and so on, and actually joining these groups together. Because the question just wants us to draw the graph, we're just going to skip that step and cheat a little bit and do a running total instead of just the frequencies. Don't be confused, you don't need to use both of these columns up at the top. So if we do a running total of the frequency, that one is 6. We then add on 16 to represent everybody from 40 to 60, so this gives us 22. Then add on your 28 to give us 50. And finally add on the 10 to take us up to 60. Always useful because it normally will always do this. It will normally tell you what the total of frequencies actually is, so you should have the same number at the bottom of your cumulative frequency as that. In order to draw the cumulative frequency diagram, it's been quite nice on the question and actually drawn the axes for us. So all we're going to do now is plot some points and join them. So here we go to the end point of the group whenever we're drawing cumulative frequency graphs. So cumulative frequency, you must remember, at the end point. So for the first one, we would need to go along to 50 and up to the cumulative frequency of 6. So if we go along to 50 and up to 6, be careful of your scales, that will give us a point just there. The next one, along to 60, up to 22. So we go along to the end point of the group, so 60, up to 22, so that's going to be just here. Third point, we need to go to 70 on the bottom and up to 50. So if we go along to 70, up to 50, put our little point in there. And the last one, so along to 80 and up to 60. So along to 80, up to 60 will give us a point there. Now this is a point that people lose all the time in exams. Cumulative frequency is a curve. So when you get to an exam and you're asked to actually join these points together, you need to try and ensure you draw a single, smooth, or as smooth as you possibly can, continuous curve. Now I'm not going to join this down to the corner here, to 0, 0, for the pure fact it's got this little shortening here between 0 and 40. General rule of thumb is if you actually leave it at the very last point, you're normally going to get the marks in pretty much every question. So I'm not going to join that to the bottom because actually in some questions that would be inappropriate to do anyway. So here is your cumulative frequency diagram. Now the final question we're actually going to have a look at actually links in with this. Now the final question is this. So here we need to try and work out the interquartile range using the graph that we've just drawn. So if we go back to the graph, the interquartile range is two values found on the graph and we find the difference of them. The two values we need to find are the upper quartile and the lower quartile. Now the lower quartile is a quarter of the way through all of the values on the table. So because this graph and the table represented 60 cars, to find the lower quartile we would need to read off whatever a quarter of 60 is. Well, a quarter of 60 is 15, so we would take our ruler and at 15 we would need to draw a little line going across from 15 until we hit the curve and then straight down. You'll have a little bit more time in the exam to make sure you're 100% accurate with this. So to me, if this was a little bit more accurate when I drew, that would come out, I think, as 55. That would be my lower quartile. And for upper quartile, it's 3/4 of 60. So the upper quartile is 3/4 of the way through the data. Well, if that was 15, 3/4 would have to be 45. So I'd do the same thing, draw a line across from 45 until I hit the curve, and then straight down from that point until I hit the axis at the bottom. So here, this looks like 68 to me, and that would be my upper quartile. So to finish off the question, which we had here, to work out the interquartile range, we do the upper quartile, which was 48. No, it wasn't, it was 68, misreading my own writing. Make sure you don't do that in the exam. Take away the lower quartile, which is 55. Well, 68 take away 55 is 13, and we put that in as our interquartile range.